Hello and welcome to the AI Learning Place. This is a series where curious agents explore the world of artificial intelligence. Each week, we'll explore different topics of AI, from the basics to the latest advancements. And today, we will uncover the secrets behind artificial intelligence. Last time, we talked about neural networks and their role in AI. But have you ever wondered, how do these networks actually learn? How do they improve over time to make better predictions? Well, today we'll dive into gradient descent, explore how AI generalizes knowledge, and even look at how AI is revolutionizing biology with AlphaFold. Exciting stuff, right? Let's get started. Alright, let's get right into how neural networks actually learn. How do they get better at recognizing things, like handwritten numbers or cat pictures? Well, it all comes down to something called gradient descent, the secret sauce behind AI learning. Let's think about this in a fun way. Imagine you're at the top of a huge mountain, blindfolded. Your goal? To reach the lowest point, the valley. But since you can't see, you can only take tiny steps downward, feeling where the ground slopes. Slowly but surely, you make your way down. And that's exactly how neural networks learn. Instead of a mountain, we have a mathematical landscape, a special function called the cost function, which tells us how wrong our AI is. The lower the cost, the better our AI is performing. And just like our blindfolded hiker, AI follows the slope of this landscape, taking small steps to improve with each round of learning. Now, let's connect this to actual neural networks. In a classic MNIST digit recognition task, each number is a 28 by 28 pixel grid, so our neural network has 784 input neurons. But did you know that inside, it has over 13,000 adjustable connections, called weights and biases, that need to be fine-tuned to get the right answers? AI starts by guessing randomly, which, let's be honest, is terrible at first. But every time it makes a mistake, it updates these weights using gradient descent, slowly tweaking itself step by step, just like adjusting your path down the mountain. Over time, it gets better and better at recognizing patterns. So what's the AI actually trying to do? It's trying to minimize something called the cost function, a mathematical formula that measures how bad its predictions are. A high cost means the AI is making a lot of mistakes. A low cost means it's learning well. With each step, gradient descent helps AI take the best possible direction to reduce errors and improve accuracy, kind of like a personal trainer guiding an athlete toward peak performance. Here's a big question. Is AI actually understanding what it sees? Or is it just memorizing patterns? Some networks get really good at training data, but fail when faced with something new. It's like if you memorized all the answers to a math test, but had no idea how to solve new problems. That's a challenge researchers are still working on. Can AI truly think? Or is it just an advanced pattern matcher? What do you think? Let me know in the comments. Now that we know how AI adjusts itself through gradient descent, let's dive deeper. How do we know if an AI is really generalizing knowledge instead of just memorizing? Let's explore how neural networks handle structured versus random data. Neural networks are powerful, but there is a catch. Sometimes they don't truly learn, they just store information like a giant cheat sheet. So let's dive into this mystery and see what AI is really doing. Imagine you're studying for a math test. You have two choices. You can understand the formulas and learn how to solve different problems, or you can memorize all the answers without knowing why they work. Which one do you think will help you in real life? Well, AI faces the same challenge. It needs to find real patterns in data, not just memorize answers. This was explored in the discussion with Lisha Lee, who showed that when AI is given meaningful, structured labels, it learns well. But when the labels are random, the AI still finds a way to memorize them without actually understanding any general rules. To truly learn, AI needs structured data, meaningful relationships between input and output. This helps AI recognize patterns that apply to new situations. But if the training data has no real structure, the AI can still memorize it but won't be able to generalize new data. Think about it. If AI just memorized every cat picture it has ever seen, but you showed it a cat in a different pose or lighting, it might fail to recognize it. That's because true intelligence requires generalization, not just memorization. Now, let's take this idea to a whole new level. AI in science. DeepMind's AlphaFold is an example of AI discovering real structures in nature. This is where AI stops memorizing and starts making breakthroughs. kind of like how mathematics helped structure physics. In his Nobel lecture, Demi Hassabis, CEO of DeepMind, explained how AlphaFold solved one of biology's biggest mysteries, predicting how proteins fold. For decades, scientists struggled with this complex problem, but AI was able to find a structured pattern in nature, helping researchers understand diseases and design new medicines. This is huge because it shows that AI can do more than just repeat information. It can actually unlock hidden rules in nature. So, is AI really learning or is it just memorizing? Maybe it depends on the data. AI like AlphaFold shows us that when patterns exist in nature, AI can uncover them. But when randomness is involved, AI struggles to truly generalize. What do you think? Could AI one day truly understand the world the way humans do? Let's talk about AlphaFold, DeepMind's incredible AI that solved one of biology's toughest mysteries, predicting protein structures. So, why is this so important? Well, imagine trying to predict how a protein folds. It's like trying to guess how a string of beads will twist and turn in 3D space. Scientists struggled with this problem for decades, and then along came AlphaFold, an AI that cracked the code. AlphaFold can predict protein structures with atomic accuracy, helping researchers understand diseases and develop new medicines faster than ever before. This isn't just theoretical. Over 2 million scientists are already using AlphaFold worldwide. Let's put this in perspective. AI has already mastered games like chess and Go, but now it's moving on to something much bigger, which is decoding the secrets of life itself. Think about it, AlphaFold isn't just memorizing data. It's actually discovering new rules about biology, similar to how math provided a structure for physics. And here's where it gets even crazier. Scientists believe AI could one day simulate entire biological systems. Imagine an AI that understands how cells interact, how diseases spread, or even how new medicines might work before they're tested. This could revolutionize medicine, environmental science, and so much more. So, here's the big question. Will AI become the ultimate tool for scientific discovery? Could it help us unlock the fundamental laws of life the way physics unlocked the laws of the universe? Let me know what you think in the comments. And coming up next, we'll explore something even more exciting, an alternative to traditional deep learning called Kolmogorov-Arnold networks, or CANs. Could this be the next big leap in AI? Let's find out. We've seen how deep learning and neural networks are changing the world, from recognizing patterns to revolutionizing scientific discovery with AlphaFold. But are neural networks the best way to model intelligence? Most neural networks learn by adjusting weights and activations, like fine-tuning a giant web of connections. But CANs take a different path. Instead of relying on layers of neurons, CANs focus on mathematical transformations to process information more efficiently. Imagine solving a problem not by trial and error, but by instantly finding the perfect equation. That's what makes CANs exciting. They could potentially solve complex problems in a more efficient way than deep learning. Could CANs be the next evolution of AI? Will they replace traditional deep learning? Or will both approaches work together to push AI even further? This is an exciting area of research, and we're just scratching the surface. In future videos, we'll explore how CANs work in real-world applications and whether they can outperform today's most powerful AI models. Do you believe CANs could redefine the future of AI, or will deep learning continue to dominate? Let me know what you think. Overall, today we finally explored some of the most exciting concepts in AI, starting with how neural networks learn using gradient descent, then diving into the big question of whether AI truly understands or just memorizes patterns. We also saw how AI is changing science with AlphaFold, helping researchers unlock the secrets of biology. And to wrap it all up, we took a peek at Kolmogorov-Arnold networks, a fresh approach that might reshape the way AI works in the future. If you enjoyed this video, make sure to hit that like button, subscribe, and turn on notifications so you don't miss our next AI adventure. There's so much more to explore in the world of artificial intelligence, and I can't wait to dive into it with you. Thanks for watching, and as always, stay curious, keep learning, and I'll see you in the next one.